All right, welcome back. Video 4, arcsecant. Let's take the derivative of arcsecant or inverse secant. So, step 1, of course, as usual, take the secant of both sides. We can now use implicit differentiation to take the derivative. We happen to know that the derivative of secant is secant times tangent. And the chain rule says I have to then multiply that by the derivative of the inner function. And the derivative of x is 1. So the derivative with respect to x of arc secant of x equals 1 over secant y tangent y. So let's get this in terms of x. Very quickly, a couple things that we know right off the bat, that secant y is equal to x. So that's just going to be a 1 over x. But what do we do with tangent? Well, we know that tangent squared is equal to secant squared minus 1. Secant squared, of course, secant of y is equal to x. So this gives us that tangent of y is equal to plus or minus the square root of x squared minus 1. Doing a little simplifying, we get plus or minus 1 over x square root of x squared minus 1. Now, here's the problem. I'm not a big fan of this plus or minus. It means that when we try to take the derivative of secant, we're going to get two possible answers, and we don't know which one it is. So let's take a quick look at the graph of secant to perhaps explain what we could do to simplify this. And what we get is that the graph of secant looks something like this. Oops, excuse me, not like this, like this. And this is -1, and this is +1. Well, notice that the slope of this function is greater than 0 for all values of x. The reason we end up with a plus or minus is because if x is greater than 0, I'm going to use the plus. And if x is less than 0, I'm going to use the minus to ensure that it's always positive. So, simple solution. We'll just turn this right here into an absolute value, and then we don't have to have the plus or minus. So what we end up with is that the derivative with respect to x of arcsecant of x is equal to 1 over the absolute value of x times the square root of x squared minus 1. And of course, the usual caveats of if it's arcsecant of u, where u is a function of x, we use the chain rule and multiply this by the derivative of the inner function. So let's look at a quick example. Let's find the derivative with respect to x of arcsecant of 5x to the fourth. So we'll let u equal 5x to the fourth. The derivative of u is 20x cubed. The derivative with respect to x of this function is therefore 1 over the absolute value of u times the square root of u squared minus 1 times the derivative of u, 20x cubed. Notice that the x cubed could be positive or negative, but the x to the fourth will always be positive. So the answer to this function could be positive or negative depending on where you are. So when we simplify this, what we get is that we don't have to write the absolute value anymore, but there's going to be a 4 up here, and there's going to be an x left over down here, and it's 1 over x times the square root of 25x to the 8th minus 1. And notice again, I'll just reiterate that we do lose the absolute value symbol when we simplify, because we have something that could be positive or negative divided by something that is always positive. The answer could be positive or negative. So don't make the mistake of leaving the absolute value in that solution. Whoa, I forgot a 4. Whoop, sorry. My bad. That 4 came over here. All right. If you are in one of my classes, please go ahead and do exercise 17 in the book. You can check your answers in the book or on the Slater.com website. And then I'll see you back here for the next video. Thanks for watching.